one?
The blue and pink one?
Yeah.
Alright, why don't you come up and explain this?
Okay.
Tammy, come on. Natalie, you can move over so Tammy can get in.
Okay. So, well, first of all, we started out we didn't really understand what we were doing. But then, Miss Alzheimer came over, and so she moved the tiles around to, like, she took this away, and she said, like, how can you figure out an equation with, like, this, okay? And so, we figured that, wait, what was it?
That if you take this, since this is like one side, because you have 3 of the side length plus corner tile on each side. So we said that if you multiply that by 4, you would get the amount of tiles.
And so then, first we wrote it without the brackets, and then Miss Asma said, then if you think order of operations, it says multiplication first, and that's what we don't want, because we want to figure this out and then multiply it for, so then we put in the brackets. And then if you just take away that and you show it 4 times, that's what that looks like.
Because it's, well, this says S1 plus 1 times 4. Same thing as saying add this 4 times. So that's what we did. S1 plus 1, S1 plus 1, S1 plus 1, and S1 plus 1. And S1 plus 1 means that you have it means that you have one side length, and then plus 1 of these, which is 4 more. Do you understand? Okay. You have one side length, which is 3 of these, plus 1 of the corner tiles. So it's like,
Why don't you group it?
it's like taking this.
Okay, that's one of their chunks.
So you take this, that. That's 4. So so you take S1, one side length, plus 1 of these, 4 times. Okay.
I think she's saying that you have to multiply one whole side plus the corner 4 times for each side length of the square.
Okay, and then our other equation was, okay, so we figured that, side length equals 3, right? So 3 times, 3 4 times, right? So then we just figured that, then that is 4.
Okay, you have the side lengths equals to 3. You have 4 of those side lengths. So we put that in as 4 side lengths. So then you have
So it's 12. So then 3 4 times is 12.
3 times
Then
4 times.
we had to add the 4 extra ones. So then, since we're trying to figure out the number of tiles, not the perimeter, because at first we thought it was 8, which was the perimeter, and then she said we're trying to figure out the number of tiles. So then we just put 4, so it's 12. No, yeah. So then it's that times 3 plus 4.
Okay, 3 times 4 equals 12 plus 4 equals 12 plus 1.
What?
16?
Yeah.
Alright, forget it. 16.
Can I step in for a second? You guys are doing a fantastic job. I want to see if I write something on the board, if it makes their 2 equations more clear. Could you back up just a tad? Okay, so their one equation was n equals s plus 1 times 4. And I think we all see that this is a group of s plus 1, here's a group of s plus 1, here's a group of s plus 1, and here's a group of s plus 1. How many groups of s plus 1? 4. So you take s plus 1 and you multiply it by 4. Then they did another equation. Let me ask you, if you had 3 times 4, what's another way to write that without using multiplication? Amber?
3 to 4 in brackets.
Okay, but forget the whole
Like,
concept of multiplication. Use a different operation, not multiplication. Shayna?
6 plus 6.
Okay, yes, that is correct. But let's use the numbers. Let's use what we have here. You're right. But I'm trying to get at a relationship between multiplication and another operation. Claire?
3 plus 3 plus 3 plus 3.
How many times did I add 3?
4.
Amber?
4 times.
You see what I'm getting at here?
Yeah.
So then how did they rewrite this?
Put it 5 times.
5 times.
That's,
5 times?
4 times, I think.
S plus 1, how many
4
times?
times, yeah, for each side.
One, two, three, 4. The same thing as S plus 1 times
Yeah.
4. Do we think that's true?
Yes.
Now how about, what? Did I forget something? No? Okay, so now. No? Okay, so now we've got these two equations that they figured out. 1, 2, and this one that we started off with. Are these all the same? Who thinks yes? But they look different. Things are not in the same order, things are not grouped the same way. How could they be the same? Remy?
I think they all are the same. They're the same because it doesn't depend. It like doesn't matter where the numbers are in a certain place in the equation. It's order of operations and how you solve for it.
Okay, anybody want to add on to that? Steph?
Well, actually, I think that both equations are the same because, like, the first one, if you solve, 5 plus 1 is 6, and then 6 times 4 is 24, and then the second equation, 5 plus 1 is 6, and then 5 plus 1 is 6, 5 plus 1 is 6, 5 plus 1 is 6, and you add those all together and you get 24.
Okay, so what method did Stephanie use to check if they were the same? What did she do? Leo?
He substituted a number for both equations in both equations and solved them, and they were equal. They were the same.
Perfect. Do you think that'd always work? Yeah. Do you think you only need to check one number? What do you think? I want you to think about that. Can you check for equivalency in these expressions by only substituting in one value to check? We're not going to talk about that right now because we're running out of time, but Lulu, I would like